I'm converting my old golf cart from lead acid batteries to lithium, but I don't want it to cost more than the cart is actually worth, which might be, I don't know, $1,000 on a good day. Stick around, I'll show you what I got going on. I am so done with lead acid batteries. This is the third set I've had in this golf cart, and these are now toast also. There's a myriad of problems with this type of battery, and replacing them with the same type doesn't make any sense when the alternatives are so much better and affordable now. And therefore, now that I have to replace these, I'm going to be switching over to a lithium battery. Now, converting your golf cart from lead acid to lithium is not quite as simple as just pulling out all your batteries, putting a lithium battery in, hooking up a couple of cables. There's a little bit more to it than that. I've ordered the specialty components that I need to complete this conversion from a few different sources. Now, this is not going to be some long unboxing video, but I will provide more information on the components as I install them. Just an FYI, this is not a detailed step-by-step instruction video on doing a lithium conversion, but rather an overview of the steps involved with some good-to-know information along the way. However, if you have any questions about anything in particular, leave that in the comments and I'll respond with as much detail as I can. Now let's take a look at the battery. This is the lone battery that I'll be installing. It's a 36 volt, 65 amp hour lithium iron phosphate battery from Enjoybot with self-heating. Self-heating? What's that? Lithium cells can be damaged if they're charged when the temperature is too low. Self-heating batteries have a heating element that will warm the cells before it allows the battery to be charged. I use my golf cart year-round to get around the farm, and I live in Michigan, so there will be times when I need to charge the battery when it's freezing outside. So this feature is a must for me, obviously not something that everybody would need. Self-heating is just one of the functions that's handled by the Battery Management System, or BMS. A component that is internal to the entire unit. It also prevents overcharging and over-discharging, both of which can damage the battery, a protection that lead-acid batteries don't have. The lead-acid battery array that this is replacing has a rated capacity of about 200 amp hours. So doing quick math, you might say, hey, the new battery you're putting in has only 1/3 the capacity as the old battery pack and thus only 1/3 the range. Well, not really, because rated capacity works a bit differently with lithium batteries. Realistically, you can only use half the amps of the rated capacity of a lead-acid battery or risk causing damage. Therefore, you only have 100 usable amp hours from a 200 amp hour battery. Whereas lithium batteries can safely use 100% of their rated capacity. Although for the most part, you're not going to want to go much past 95% depth of discharge. So if we redo the math with that in mind, the 65 amp hour lithium battery has 2/3 the usable capacity as the old lead acid battery pack. Still not as much, however, consider that the lithium power will also weigh 330 pounds less. That's 1/3 of the weight of the golf cart. That will make up for some of the smaller overall capacity as the cart will be more efficient, therefore you can really stretch your amp hour dollar. The 65 amp hour lithium battery is a common size to swap in for a 2-seater golf cart. You'll also see the 100 amp hour batteries used for greater range. My cart doesn't have the room for one large battery unless I move the drive electronics. Basically the speed controller, solenoid, and throttle rheostat to the side here, which involves a bunch of fabrication that I don't feel like doing. Besides, I can't find a 100 amp hour battery with the self-heater anyway, so the 65 it is. This is a specialty tool. It's a battery lifter that I have because I've done this job several times before, and I'm happy to report that this should be the last time I have to use the stupid thing. I think it's a miracle that I actually found it since I last used it 4 years ago. That's not to say that I can't lose a tool that I used 4 minutes ago, because that's a thing with me. It's a good idea to take pictures of all the connections to the positive and negative hookups of the battery array before starting to disconnect anything. As I'm unhooking all these batteries that are connected in series, it reminds me of another benefit of this lithium swap. The new setup will be simpler with less cableage, and yes, cableage is a word now, and that means less points of failure. I have had breakdowns where a cable was the problem. It's interesting now that I'm editing this video and watching this part and fast forward just how much the ride height of the cart keeps increasing as I continue to pull the batteries out. And keep in mind, the one battery I'm putting in weighs less than one of the 6 that I'm pulling out. The battery tray in these carts is always susceptible to accelerated corrosion because of the nature of the lead acid batteries. This one wasn't too bad because I've cleaned it up and sealed it 2 times before when I changed the batteries. So just another quick coat of sealer is all I needed here. Also, the new battery has a bigger footprint than the old ones, so it's not going to fit neatly into this battery tray. So I'm going to put a floor in here for the battery to sit on. This is the battery gauge for the old lead acid battery pack. It's basically a voltmeter with a limited scale of maybe 25 volts on the bottom end and 45 or so on top. And this worked fine before because with lead acid batteries, as you pull amps out, the voltage drops in a linear fashion, and therefore reading the voltage of the pack will give you a good idea of the remaining runtime. The discharge curve of a lithium battery is much different. It'll come off its peak voltage real quick and then sit at its nominal voltage for most of the cycle of the pack, and then at the very end it falls off a cliff. So if you're monitoring a lithium battery the same way and you read X number of volts, you won't know if it's here on the graph where you've got about 80% left or here where you're in the 40s. Now this graph is showing the discharge curve for a lithium ion battery, but the discharge curve for lithium iron phosphate is nearly identical as shown here. I don't know where I got this graph from, but voltage is spelled wrong. With that established then, we're going to use this instead to determine the state of charge of a lithium battery. This monitor doesn't use voltage, but rather tracks amps in and amps out of the battery to determine the state of charge. And that is accomplished by installing this shunt, which is that gold block on the right side, in line with the negative side of the battery. And all of the current going in or out of the battery is measured by that shunt, and the data is sent via cable to the monitor. I hooked up the new battery temporarily just to take the cart for a quick spin to see how it works, and I don't have the 12 volt system hooked up yet, thus no lights, but bonus, this is an older cart, has a steel body, and therefore my magnetic work light works pretty good to light the way. And this is supposed to be a temporary solution, but it actually works pretty good. Although it'll be gone going forward, I hooked up the new battery to the old meter just to see how much of a voltage sag there was under load, and it turns out it's practically zero. The standing voltage and the voltage under load are nearly identical, which is awesome. And for comparison, just for fun, this is a video I took of the old lead acid battery pack before I took it out, just to see how tired they were. And this begs the question, how much voltage sag do you want? And the answer would be yes. I need to get behind the dash to get this new meter in. I've already unscrewed and removed the cup holder here. The bonus about building your dashboard out of leftover laminate flooring is the sheet metal flange at the top of the opening fits right into the factory groove of the flooring, and then the bottom is held in with a couple pan head screws. And it cleans easily with a Swiffer. This is the data cable that connects to the monitor up front to the shunt right back here where I mounted it on this back plane. And now this is not one of those newer carts that has channels in the floor where you can run wiring up to the front. So I need to get it through one of these looms that runs underneath the cart to the front. This is stuff that I added years ago when I first bought the cart. And this cable does need to be protected because of the way I use the cart. Now when I first got it, it was on-road only, but then after I bought the farm, then bought the farm's not a good term. When I purchased the farm, I brought it here and started taking it off-road into the fields and stuff like that, and now the bottom is susceptible to damage, like this. Now you're going to love this. Now this box right here, this is not factory. I added this as an acoustic enclosure for the subwoofers on the other side. Now I need to run that data cable up through here, so I need to pull the panel off so I can get access. And what did I find inside? Some damn chipmunk is using this for a storage facility. And I don't know when this happened because I rarely leave the cart outside when it's not in use. But this is just a reminder of why I hate chipmunks and squirrels. And you know what? So does my dog. There are lithium battery monitors that are round that would fit right here into the hole from my old meter. But of course, the monitor that came with my Enjoybot battery is rectangular because, of course it is. Cutting this out to fit the new one is going to kind of suck. Here is the lithium battery installation. The floor I installed over the existing battery tray is 3/4 inch plywood. There's a couple locator blocks to keep the battery from shifting. I had some threaded rod lying around, so I put that through and attached it to the new floor. And I designed and 3D printed a battery hold down. And this here is not a hold down strap, it is a carrying handle for the battery, which is removable. However, I'm going to leave it on here, otherwise I'll lose it. On a more positive note, we'll take a look at the connections to the plus side of the battery. Most of the wires and cables that connected to the positive lug on the old battery bank will connect here. The positive motor cable runs to the speed controller, as before. Now keep in mind, this is a way old golf cart, so your connections may vary, especially those where everything wires into the controller or has an onboard computer. One of these 14 gauge wires runs to the key switch. Turning the key does what it always did, which is energize the drive solenoid circuit. The drive solenoid is that click you hear when you push on the pedal. Another connection powers the DC to DC converter. Of course, that's what provides the 12 volt power for the accessories, lights, radio, and so on. Now that's not a direct hookup, it's actually switched through this relay, which is energized when the key switch is turned on, and that's a new circuit that I branched from the key switch. Now it's my understanding that this can be trickier with some other golf carts because the key switch circuit is de-energized when the forward and reverse selector is in neutral, in which case all your accessories will switch off momentarily when you change direction. Not going to be the case with mine, as that key switch circuit is independent, so that's good. And you might ask, why does that transformer have to be switched? If you just turn off all the 12 volt accessories, won't it just stop drawing power from the battery? No. Even if there's no load on the 12 volt side, the converter will continue to use some power. Not a lot, but we still need to have it switched off to eliminate what is essentially a parasitic drain if not in use. Ultimately, there'll be another line here for the charger. Possibly it'll go to the external port like before, or it might be wired into an onboard charger. That has yet to be determined. One thing from the original cart schematic that used to be connected to the positive here, that never will be again, is the reverse buzzer. I disconnected that nonsense a long time ago, and even if I wanted to hook it back up, I couldn't. It's only 6 volts. It was originally bridged across the poles of just one battery. I might even just hook it up across the full 36 volt load to fry it on purpose, just because. And lastly, a new line that goes to power the electronics of the shunt. Not only does it need some power to run the circuitry, but it also supplies power to the module on the dash. And speaking of the shunt, and I don't mean to be negative here, but the B- terminal of the shunt runs with the battery cable to the minus side of the battery. These are the only two connections to these terminals. Everything else, 36 volt grounds, will connect to the P- side of the shunt. That includes the negative battery cable that runs to the speed controller and also the line for the charger. This way, any current running in or out of the battery goes through the shunt and is metered. Back to the DC to DC step-down converter for a minute, sometimes also called a buck converter. That's buck converter. The 12 volt line has a maximum output of 20 amps and it runs directly to the main power switch on the dashboard. All the 12 volt accessories branch from there. I added this indicator that's on anytime the 12 volt system is on. That way it's a reminder that that converter is powered up and to turn off the key if not needed. One of the catches to going to lithium though is that you need a lithium specific charger, and that's not necessarily a bad thing, especially if you have one like this, which is about the size of one of those old lead acid batteries and probably weighs about as much as one too. It's not exactly portable, and you're certainly not putting it on board the golf cart. Currently I have this portable charger specifically for a 36 volt lithium battery. So for now, this is how I charge. Clamp the positive directly to the battery, and don't forget we don't connect directly to the negative terminal, but rather the P- side of the shunt. In the future, I'll either adapt the charger leads to use an external charging port, or I might get an onboard charger, which would mount right here. I got the battery monitor set up and all the settings in, and this could actually be a whole video in itself, and I'm not even sure if I got the settings right. The instructions were pretty much useless. I had to do some digging around on the internet to see what some of these settings might be, and again, I'm still not sure if I have them right, but I think I have them close enough to be able to do a little testing. Right now, I'm sitting in the cart still. I don't mean I'm still sitting in the cart. I mean I'm sitting in the cart and I'm not moving. The cart's not moving. And what the battery monitor is telling me is that there are 60 amp hours left in the battery, which is 94% full. The current voltage is 39.4. It's drawing 1.51 amps right now because the lights are on, and that is 59.9 watts. And it can sustain this state for almost 39 hours before the battery goes dead. Of course, most of these numbers are going to change once I start driving. Before I go out for my little late night test drive, a couple things I want to mention, not related to the battery swap per se, but it is golf cart related. As I mentioned earlier, this is an older golf cart and it has this stubby little forward reverse selector at the front of the seat pedestal. I didn't realize how awful and awkward it was until I got this aftermarket shifter lever. So much easier to reach and less effort to move. If you have a cart with one of these little shifters down by the floor, I highly recommend one like this. It's dark outside right now, and that reminds me of something else, and that is those D-bags with these obnoxious lighting setups. The ones that drive around the campground blinding everybody they pass on the road, and all the people sitting around their campfires, and they disturb the wife and kids who are already asleep in the camper. This is my more reasonable lighting solution. 2 6-element single-row LED driving lights. They light up just what I need to see, and not a bunch of stuff I don't. They're small and they can be mounted out of the way where they're not susceptible to damage, and they're not using 3 times the amount of power from my battery than necessary. Okay, now it's time for a test drive, and I really can't compare this to, say, a fresh set of lead acid batteries because it's been 4 years since I had those. But I'm sure it's peppier. I don't see how it couldn't not be, and it's driving exactly how it's supposed to. And now what I'm not going to be able to do right now is do a range test just because of the conditions. It's been raining like this for 2 days, and we had about a foot of snow on the ground. That's all melted now, so there's a lot of water. The driveway is pretty soft and muddy, lots of puddles. All the other areas, the fields and the grassy areas, are pretty much all waterlogged and swampy. So there's nowhere I can drive right now that's not going to have a lot of added rolling resistance that I normally wouldn't have. And they're calling for rain over the next couple of days still, and so this place isn't going to dry up anytime soon. Therefore, the range test is going to have to wait for another video, so keep an eye out for that. And now the big question that some might be asking right now.
What'll it cost, man? What'll it cost?
At the time of this recording, March of 2025, a combination of purchases through the Enjoybot store and Amazon, a system similar to the one I just installed would cost right around $800. Now the reason I say a system, quote, similar to mine is because the offerings, features, and package deals seem to change regularly. More specifically, that price includes an onboard charger and also Bluetooth in the battery, which mine doesn't have. And $800 is less than a new set of lead-acid batteries, and the lithium battery has a 10-year warranty. Lead-acid golf cart batteries have what, a 1-year warranty? Maybe? I'll put my affiliate links in the description for both the Enjoybot store and Amazon for some of the other golf cart related items shown in this video. However, be sure to do your research first, especially with BMS rating. If you load your golf cart heavy or pull hills a lot, you may need something with more than 100 or 120 amps continuous discharge. To restate what I said earlier, if you have any questions on specific details of the install or the components, be sure to ask them in the comments and I'll be sure to respond as quickly as I can. I'll be continuing to evaluate this setup further and follow up with videos, including a range test as soon as the conditions are more typical. So be sure to subscribe so those videos will come up on your feed when I release them. Thanks for watching, and we'll see you next time.